So as you dive into Erlang or Elixir, you'll notice that the languages and the runtime is somewhat different than what you might have seen in other languages. And you might wonder why. So Erlang was created by Joe Armstrong, Mike Williams, and Robert Verding at Ericsson. Bjorn Decker was also involved. And they were at the computer science lab. They were trying to figure out how to build the next generation of telephone switches. And telephone switches are those wonderfully unsexy, boring devices that make, the global telephone network run. Kind of, not what you call exciting. They're not what you call flashy, but they are what you call really important. And they have very strong regulations around them, both from government regulators as well as from places like contracts and things like that. It depends by the country. But you can imagine that, when you pick up your, back in the day, landline or now cell phone, and try to make a call, you want it to work. Right? You want to be able to pick up the phone, get a dial tone in landline parlance, and make a call. So this has some very strict requirements. You can't say, take the phones offline for an hour to upgrade software like we in the internet biz sometimes do. You need to be able to handle a wide number of calls. There's, a certain that if, the switch can only handle 100 calls at a time, it's not a viable product. It's got to run for years on end. It's going to handle a hardware failure. If your switch somewhere gets hit by lightning or its power supply catches on fire or any of 100 other hardware faults happen to it, the system has to simply correct that. Also has to be what's called soft real-time, and I'll get into that in a future video. But basically it has to respond quickly, but not within the strict bounds of what you call a hard real-time system, where if it ever goes above a certain time threshold, it's inherently an error. It also has to isolate faults. If the telephone system drops my call, that's annoying, but it needs to be isolated, so it can't drop all the calls. Dropping one is okay, not great, but okay, we can deal with that. Dropping 100,000 at once, not so good. So if you take all those requirements, and they took all those requirements, and they looked around at all the languages that were around in the late 80s, early 90s, they looked at, C++ and C and Pascal, and Java wasn't around then, Smalltalk, and, other things. And they discovered that nothing really did that in a way that was particularly easy to use or, good or anything like that. So they came up with their own thing, which originally was written in Prolog, which explained some of the syntax, and now was engineered in C. And it has all these properties of it can isolate and remove faults through strict isolation processes. It can handle lots of users and all these things. So the great thing about this is, for those of us working in web applications and things like that, if you look at it, our requirements are very similar to what Erlang and the Erlang team was solving at Ericsson in like 1990. Suddenly we have 28, 30 years of engineering solving a problem that we didn't even know we had 30 years ago. Instant win. So that is some of why Erlang looks the way it does and performs the way it does, and by extension Elixir, because Elixir builds on top of that base. And that is why it is so valuable in that it can handle those things. In addition, since it has its own process model, when multi-core came out, it was back in 1990, we didn't have multi-core processors, really. Multi-processor computers, that wasn't a thing. I mean, a few existed, but they were just experimental things. When we started getting multi-core processes like we have now, we didn't have to, worry about it. You could simply do it all in the runtime level, and we handle them quite nicely. So anyway, that is why Erlang came about. If you found this useful, please like and subscribe. If you have questions, feel free to leave a comment or reach out for me on Twitter.